We will have a quiz on Monday. And then let's just go through each and every one of these problems. Stop me if you're not sure of something. There's one thing that I'm going to do that is a little bit different than a lot of if you've seen this before, it might be different and you've seen it this way. And it has to do with when we're dealing with the fractions. I have a way that it's called clearing the denominator that really makes a lot of sense. It's really a cool method once you get it down. So, so write these along as I work them out. I think I'm okay with. Problem number. I'll just work them quick. 1 and 2. I'll just go quickly on. All right, so problem number 1 is 5 quantity x plus 3 equals negative 10. Are you all okay? Feel good that you're just distributing over this to get you here? And then once you get there, I'm not going to talk through every step because we've done these a ton. Stop me if you do have a question, if you don't see where a move was made. That's the first problem. Okay, so that one I think is pretty straightforward. Number 2 gets a little tougher because there's a few places where students could make an error. One of the first spots you're going to make, there are students that could make an error, is they'll distribute 3 over to everything, but they don't distribute the negative as well. The negative 3 has to go to both parts up here. Okay, so this whole thing has to be distributed here and here. So the 2x stays as is. You get minus 18x plus 6 equals negative 64. Now let me just pause there. Realize it's a negative 18 because I'm going negative 3 times positive 6x. It's a positive 6 because I have a negative 3 times a negative 2. Is that all right so far? Okay, so we're going to combine our like terms. So over here we have these as like terms. So when I say combine like terms, you are on one side or the other as far as the equal signs go. And then solve from there. Negative over negative is positive. And this would actually reduce to 35 over 8. Is that okay? So again, on that one, where your error is going to take place is you don't distribute the negative when you're supposed to. And that's an easy place where students might make an error. Number 3 is pretty straightforward. Number 3, 4n is equal to 18 plus 2n. On this one, subtract 2n. Let's get that. And then number 4, you have this. Distribute. Notice those signs both stay the same because I distribute a positive over. And so that's going to be 5x plus 6 equals 8. 5x is equal to 2 by subtracting. X equals 2 over 5. Okay. 5, I think you're pretty, or let's see. Number 5 is going to be done very similar. Just combine like terms first. Number 6 is going to be done pretty similar. And then we get to number 7. And number 7's got 4 F words. 4 fractions. They're in there. I said it. He said he dropped. All right, so let's take a look. So remember, I'm going to go through these slow. I'm going to show you a method which is called clearing the denominator, which I think once you see this, you're going to be like, oh, why didn't we always learn that? I don't know. You guys ready? First off, has anyone ever heard the term clearing the denominator from another previous math class. Okay? So, when I say I'm going to clear the denominator, that's exactly what I'm going to do. So, right now up there, I have 4 terms. I have a 3/4 x is one of my terms. I have a negative 1/4 x is another term. I have a 5/3 is another term. And I have a 25/6 as my 4th term. Still with me in the story? Make sense so far? Okay. So what I want to do is I want to multiply all 4 of my terms by a number that will allow me to reduce and cancel the 4, the 3, and the 6. So I want you to think, what number does 4, 3, and 6 all go into pretty easily? 12. Awesome. Now some of you are like, oh, how'd you get 12? Could I do 24? You could indeed do 24, and it's the same answer. But if you look for the least common multiple, so I'm going to multiply, being that 4, 4, 3, and 6 have 12 in common, I'm going to multiply each by 12 over 1. Now I'm making it as a fraction so we can reduce it. Are we okay so far? So here's where I think the kind of fun math magic takes place. If I reduce this, 4 goes into 12 how many times? 3. So I get 3 over 1 times 3 over 1. 3 times 3 is? 9. 9 over 1 is the same thing as? 9. I don't have a fraction anymore there. That's kind of a cool little trick. Hang on. So 4 goes into 12 3 times. So that's going to give me minus 3x. 3 goes into 12 4 times. 4 times 5 is 20. All right. So I feel it's easier if we clear our denominator if we have 2 terms up front. So if I'm going to clear, I'm not going to worry about this 2 right here for right now. Okay? I want to get rid of my denominator here and here. So what number do both 3 and 6 go into? 6. Okay? Now, of course, you have someone saying, what, does 12 work? Yes, it does, but it's not necessarily the least. So what I'm going to do is I'm going to multiply both of my single terms by 6 over 1. So this is going to cancel. That gives me what on this side? 2. And then this cancels, so I have what?
6.
Huh? And? Negative 1. That is not too bad yet. I can distribute negative 1 even if one of the terms is a fraction, don't you feel? If I do this, what does that negative 1 do to both of those? Change the signs. There you go. Okay? So now, how many terms do I have? 3. I started with 2. Because I distributed over the parentheses, that gave me 3 terms. I have a denominator which is 2. If I want to clear the denominator, what do I have to multiply all 3 terms by right now? What? 2. Heck yeah. I'll multiply this by 2 over 1, or just 2, and this by 2 over 1, and this by 2 over 1. Well, 2 times 2 is 4. Negative x times 2 is negative 2x, right? What about here? What do I have left there? Oh, yeah. Subtract 29. I got $4 in my pocket. Something costs $29. Do I owe or get back? Oh. What I got? Yeah. Divided by the negative. Negative over negative is positive, so my answer is 25 over 2. Leave it like that. You do not have to make it a mixed number. Okay? So, I just showed you that you can clear the denominator more than once on a problem. What's the approach that you're going to take that makes it easier for you? And I don't know. Okay? Problem number 9. Can I clear? Problem number 9. Ready? How many terms does it look like I have? What? Well, sure.
All the time.
Can I carry around a 5-gallon bucket and just drink it?
Can't get like one of those
It's basically
mega
the
dolls
same
that like
thing.
is 7-Eleven, Josh.
Oh, yeah. Those are like
It just really annoys me when people
They
You
should
know that.
at 7-Elevens, they should have.
I don't let it bug you. I think it's awesome.
They should be able to fill mega gold.
All right. Let's get past the water and the jugs of water. I love it. No, just look until it stops bleeding.
I think I have a Band-Aid.
You have that extra Band-Aid on you?
No, that's
We have the extra one over here.
no, I literally have a whole pack of Band-Aids.
Oh, do you?
Back when there was black and white TVs.
We got Band-Aid taken care of. Don't worry about it.
They
All right.
have Band-Aids.
In 3 and 2 and 1, back to it. Let's do it. How many terms do I have sitting there? A lot. Too many. Okay? Let's put a numerical value to it rather than an adjective.
8.
You think 8 terms?
5.
5 terms? So 2x is a term. Somebody shout out another term to me.
X. No, hold on. 2.
2. Someone shout out another term. 52. Someone shout out another term. Negative what? Negative 9 over 4x. And then the last term is?
Negative 1.
Negative 1/2 x. Okay, so I have 5 terms. I have 2 denominators. What number do both those denominators go into? 4. Okay? So, I'm going to multiply this by 4 over 1, which is the same thing as 4. This by 4 over 1, which is still 4. This by 4 over 1. This by 4 over 1. And this by 4 over 1. Still with me?
Yep.
Okay?
Wait, yeah, why is it 4?
Wait, why is it?
Well, 4 over 1. 4 over 1 is the same thing as what? 4. So, well, obviously on the ones that it's just a 2x, it's not really that important.
No,
Right.
I don't understand why you're using 4.
Oh, okay. I have a denominator of 2 and a denominator of 4.
Oh, it's the common.
You have least common multiple between the two. I could have used 8, and the reason I do 4 over 1 for everything is rather than saying, well, I just have to make this 4, rather than, that's what I'm doing. So what does this one get? What do we get here for an answer? 8x. Everyone feel okay with that?
Yes.
Okay. This 2 goes into this 4, so what do I have for this next term? Don't forget everything. Negative 2x. Stopping there. Following that? What about that third term? What does that become? 8. This cancels here. What do I get for my last term, or this fourth term? Almost, what is it? Negative 9x. Okay. And that's 208. Fractions are gone. Let's combine like terms. I happen to have 3 like terms over here. I have 8 minus 2, which is? Negative 6 minus 9 is? Negative 15. So I get negative 15x plus 108 equals 208. What would be next? Subtracting 8 from either side. Last step. Clear? Careful. By what? Negative 15. Then the answer is going to be negative. Does 15 go into 200? I know that 5 does. 5 goes into 240 times. And 5 goes into 15 how many times? And that will not reduce any further. Sweet. Problem. You're this close to being excused from my class. and then I will require a parent to show up with you and sit with you during my class until I let you back in. Got it? Okay, so we've cleared the denominators. So it seems like a skill that could be practiced. I think you could do pretty well. And I think I'm going to skip the rest of that page until some other time. Okay? Because I want to focus on this skill and this skill only. I'm pretty sure you all wrote this down, so in my mind, you all did the assignment, yes?
Yes.
Those of you who didn't, maybe missing out. So I'm going to give you the points for 6A right now. It's going in. If you have another assignment to work on, awesome. 6B, it's 10 problems. It's clearing the denominator. And I think if you guys take the opportunity right now to work on it, and if you don't have it, take a picture with your phone and work on it at your desk. Okay? Or you can sit with somebody who has a book and write it down in your own notebook. Okay? So let's work on 6B. Let's make 6B due at the end of the period. Hi, Cupcake.
Hi, how are you?
Doing well. Thank you, Rillo. Perfect.
My friends called
Smallest number that both 3 and 2 go into. Yeah. 6. Is everyone okay with that? So a lot of times if you're like, I can't think of it, just multiply all the denominators together. Even though that might not be the smallest, it's still going to come out the same answer. But if you can't see it right away, then just realize, you can multiply all the denominators together and come out. So 3 and 2 are my two denominators. 6 is the smallest number. They both go into. So I'm going to multiply this by 6 over 1, this by 6 over 1, and this by 6 over 1. Is everybody okay with that? Now, which one of those terms doesn't necessarily need to be multiplied by the fraction 6 over 1? The 7. Okay, but I'm going to put the 6 over 1 with each of them with the understanding that 6 over 1 is the exact same thing as the number 6. Okay, so now I can start reducing. So 3 goes into 6 how many times? Twice. So here that's going to give me 4 over 1, which is 4, and then the x comes along. The plus sign comes down. Still with me? Still with me? Okay, now I'm going to reduce this. 2 goes into 6 how many times? 3. So 3 times x is just 3x. And then I don't reduce anything here. I just multiply and I get 42 over 1, which is just 42. Stopping. Yeah.
Isn't it 2 over 3x minus x over 2? Wouldn't that be?
Is the minus sign in there? Oh, it was a plus sign right here.
Yeah.
Plus sign.
It's a plus sign?
Think. Did I see it wrong?
Minus. No, it's plus to minus. Yeah, subtraction.
Do you all have subtraction?
No.
I have addition.
Wait, on which one?
Problem number 3?
He does have subtraction.
Really?
I got addition.
I have addition too.
I have addition.
I don't have anything.
You don't.
Did you take a picture of it or write it down at least?
No,
What happened?
when I put my parentheses around it.
Oh, you just couldn't see it.
couldn't see it.
Oh, okay. Oh man, I thought, holy cow, we got 2 different sets of problems. Darn it. We ran out of books and then 2. Oh man, that's bad. All right. Hey, like terms, what does that come to? 7x. Okay. How do I solve this?
7.
Someone's just yelling out arbitrary numbers. Good. 7. Good.
You okay there?
Me? No, never. All right. How do we feel about number 3? Is there any part of number 3 that you want me to go over a little bit differently with you? And don't worry, I'm not going to be the guy that if you don't get it, I'm not going to be talking louder. It's not like we're in some foreign country and you're trying to ask you where's the bathroom. Where's the bathroom? Huh? Where is the bathroom? Like people are gonna now be able to decipher what that is.
If you speak louder, they can actually understand you.
No, if you speak a little slower and English isn't their first language, then they can understand you. But speaking louder.
If they have some
Speak
English
louder.
dialect.
Yeah, but it just makes them annoyed.
I volunteered at our church quite a bit, and I'm sometimes a little bit, I don't know, I'm not the nicest person sometimes. So a lot of times they will give us their phone number to check their kids in, and so someone will go like 303-723, and you're like, what? And then they'll say it again, and they'll just do it just as fast, what? And of course I see numbers, so I already got the string of numbers. But it's like, to me, it's like if they're too high strung and they can't spend time to go 303. That's fine. All right, number 4. How many terms do I have with number 4? I have 3 terms. Everyone's good? Anyone stuck on 3? I have all 3 terms that have a denominator. The denominators happen to be 14, 7, and 14. Do you agree? Okay, so from there, I'm going to multiply all 3 terms by the smallest number that both 7 and 14 go into. 14. Does that make sense? Now you might have someone saying, well, sometimes 14 also they both go into. You're absolutely right, but you can go with a smaller number. They both go into 14. Okay, so what am I going to multiply all 3 terms by on number 4? 14 over what? 1. We still good? All right. That's gone. What does that leave me for that first part? 9y, right? And then this one gives me what? 6. Good. And then my last one gives me what? 9. And that makes it a lot nicer looking problem. So then I'm going to ignore like terms, so I'm going to subtract 6 from both sides. Is that okay? Then what? Divide by 9? What does 3 over 9 reduce to? What? 1 over what? 1 over 3. So the answer came out to be a fraction, but we eliminated the fractions in the beginning. That doesn't mean that you're perfectly good to go. It just means it is what it is. Okay? So take a look at 5 and 6. 5 and 6 look very similar. Give both of those a shot. Try it. Try each of those, 5 and 6. See if you can start getting things to drop out pretty easily. Chill. Use measurement. Question back there? Nope. Okay, so I open up the novel. So 5 is 15 3 times, right? So that should be well, because 15 is on top and 5 is on bottom. Yep, subtracting exactly. I was just standing. Oh, I still am recording. All right, take a look. So problem number 5, I have how many terms guaranteed? 3. We still good with that? What's the smallest number that 4 and 3 both go into? 12. I like it. So I'm going to multiply all 3 terms by 12 over 1. Still with me? Okay. 4 goes into 12 how many times? 3 times. Then I get this 3 times 3, which gives me 9. Minus 3 goes into 12 how many times? 4. What do I need to make sure I bring down? The minus needs to come down, and what do I have here left? 4 and Z. Okay, and then 4 goes into this 3 times, which gives me 3. And then that's just a traditional. Negative over negative is positive, and 6 over 4 reduces 2 goes to both 3 over 2. Oh, 3 over 2, jeez, I don't know. 2. Make sense? Problem number 6. I have 3 terms. How many of you chose to multiply everything by 16 over 1? How many of you chose to multiply by 8 over 1? Sweet! 8 over 1 is how you go about this one. 16 over 1 gets the same answer as well. But I have 4, 2, and 8. The smallest number that 4, 2, and 8 I'll go into is 8. So I'm going to multiply all 3 terms by 8 over 1. Okay? 4 goes into 8 how many times? Twice. So 2 times m is 2m. Do I need to keep it over 1? No, it's fine as is. 2 goes into 8 how many times? 4. And then 8 goes into itself once. What do I have left with at the very end? 5. Okay, combine like terms, it's a 5. That's 6m equals 5. Divide each side by 6. So my answer is a fraction. That's okay. Wow. Try 7 and 8. I will tell you on that number 8, you have 2 terms because 2x minus 6 is all over 4, so that's one whole term, and then you have negative 7. So what should you multiply both sides by on number 8? 4. How many terms do I have on number 7? 3. What is the smallest number that both 3 and 8 go into evenly? 24. Good. So in this case, we're just multiplying them together. So I'll multiply this by 24 over 1, multiply this by 24 over 1, and this by 24 over 1. Okay? 3 goes into 24 how many times? 8 times. So what's my term right here going to be? What's my term here? 16x. Good. 8 goes into 24 how many times?
3 times.
So what is my new term over here going to be? Negative 15x. Awesome. This one won't reduce, but that just gives me 48. Still with me? Oh, nice. When I combine these together, I get 1x. 1x is the same thing as x. So x equals 48. This one worked out real quick and easy. And as I said on number 8, you have 2 terms. 2 terms. I'm going to multiply both sides by what? 4 over 1. So this is going to cancel that. That just brings that straight down. I don't have to distribute over. If this didn't reduce all the way, distribute whatever that would be. So technically this is in parentheses, but I can drop the parentheses now. Is equal to negative 28. Add 6. Divide by 2. Do the best you can on those last 2 problems. If you haven't gotten them done, we'll go over those 2 first thing tomorrow. Just make sure 6B is done. Cool? I actually already gave you all points for it, so we'll just